Okay, good morning, everybody, and welcome to our pre-calculus 40S class. Um, Today, we are going to be talking about lesson 8 and focusing on double angle identities. So, welcome, and I thank you very much for joining us today. So, the double angle identities are used when working with angles that are related to other angles by a multiples of 2. So, we can look at that one, multiples of 2. So these are the double angle identities. Certainly there are listed over here. They're also listed on our this is our formula sheet, the card stock that I gave you last time, the beginning of the year or semester. So this is the one, these are the ones that we're going to be focusing on for today. Okay, so I just want to kind of read this for a second. So when we have a sine of 2 times angle, so if we double the angle, so the angle, let's say, is 30 degrees, and then double that 2 times the angle, it's the same thing or equal to 2 times the sine of A, sine of alpha of the angle, times the cos of the alpha. Okay, so now what about this one here? Cosine of 2 times A. Or alpha, 2 times the alpha, the angle. That's the same thing as cos squared alpha minus sine squared alpha. And then cos 2 of alpha is the same thing as 1 minus 2 sine squared of alpha. So this is actually kind of interrelated because when we look at that one, we can substitute sine squared alpha with the Pythagorean trig identity. And if we do that, simplify it, this one's supposed to be, if we simplify this as 1 minus sine squared of A, it will produce this one. And then if we go here and if we replace the sine squared of alpha and change it to the Pythagorean trig identity, then we're going to get this one. Okay, so they're really interconnected. I just want to write it down in here so that you know what I'm talking about. So when we say cos 2 alpha is equals to cos squared alpha minus sine squared alpha, we can say, hey, cos squared alpha, that's the same thing as in trig identity. I can go 1 minus sine squared alpha minus sine squared alpha. So that's going to be 1, and then minus sine squared alpha minus sine squared alpha, that's going to be minus 2 sine squared alpha. So that's where this came to be. Okay, and then the other one is if we replace that with 1 minus cos squared alpha. So we can say cos 2 alpha is equals to cos squared alpha minus sine squared alpha. So instead of sine squared alpha, we can change that into a Pythagorean trig identity. So cos squared alpha minus, okay, I'm going to subtract all of these. So 1 minus cos squared alpha. And that becomes cos squared alpha minus cos squared of alpha. That would give us 2 cos squared of alpha minus 1, which is this one right here. Okay, so that's this one right there. And then finally, the tan 2 alpha is equal to 2 tan of A divided by 1 tan squared of A. So we don't really have time to prove all of these, but this one here, we could prove this using our the sum of 2 angle identity. Okay, so this one here we can prove using sum of angles identities. Okay, so what we're going to be hopefully finishing up today is we'll talk about evaluating uh, expression. So how do you evaluate this? We're also going to talk about proving trig identities that involves double angle identities, and also finally we're going to talk about solving equations. So let's get started with example one. Given angle theta, okay, given angle theta in standard position with its terminal arm in quadrant 3 and sine of theta is equals to negative 1/3. So what they're saying is, okay, here's the information about the theta. Information about theta is it's in standard position and it ends in quadrant 3. So let's do that. So we have some kind of a visual of what this is about. I'll do it here. So this is in quadrant 3. So this is the initial arm, and then this is the terminal arm somewhere in quadrant 3. And they said something about this. Sine of theta is equals to negative 1/3. So if we perpendicular there, this is our reference angle. So sine of theta is equals to negative 1/3. So that means the opposite is negative 1. Hypotenuse is 3. Hypotenuse is always positive. So negative 1, so which is negative 1 right here. That's the opposite, which makes sense because it's below the x-axis, so it's a negative y value, and then the r, or the hypotenuse, is 3. So what this is telling us, hey, we could figure out the x. And in this particular case, x has to be a negative value. X has to be negative because it's on the left side, right? So x has to be negative. So how can we calculate the x? Let's calculate x. Now, why are we talking about all these things? Like, why do we have to do all that stuff? Because what what we really need is sine 2 theta, okay, is the same thing as 2 times sine theta cos theta. So that's basically what we're looking for or hoping to get, because we have the sine theta. Sine theta is negative 1/3, but we don't know what the cos of theta is, and that's what we're trying to find out. Okay, so to do that, let's calculate the x using the Pythagorean theorem here. So x squared plus y squared equals to r squared. So x squared we don't know. So x squared plus negative 1 squared equals to 3 squared. So therefore x squared is equals to 3 squared is 9 minus 1 squared. So that's going to give us 9 minus 1. So x squared is equals to 8. And then we have to take the square root of that. So when we take the square root of that, we have a plus and minus value. But because this is in the third quadrant, we're going to take on the negative square root of 8 value. Okay. I know in the past you've already done simplifying radicals. So what we can do is we can simplify that radical. That's the same thing as negative root 4 times root of 2. So negative root of 8 is the same thing as negative 2 root 2. Because square root of 4 is 2 and root of 2 is just root of 2. We cannot simplify that further. So now that we have that, okay, now that we have all these parts, we can say, therefore, cos of theta is, okay, I'm going to bring it back in here. The x is negative 2 root 2. Okay, so this is the angle, reference angle. So adjacent over the hypotenuse. So adjacent, therefore cos theta is negative 2 root of 2 over 3. This is the adjacent, and then this is the hypotenuse. We haven't really done this part yet because we have to do all of these extra information. Now that we have all that, we can go ahead and figure this out. So therefore, sine 2 theta is the same thing as 2 times sine theta times cos theta. So 2 times sine theta. What's the value of sine theta? The value of sine theta is negative 1/3. Negative 1/3. So we're going to put negative 1/3 there. Times, what's the value of cos theta? Cos theta, we just figured that out. It's negative 2 root 2 over 3. Okay. So therefore, we can say, I'm just going to write it at the bottom in here. Let's see here. 2 times negative 1 times negative 2 times root of 2. So that's going to give us positive, because you got two negatives here, positive 4 root of 2. Positive 4 root of 2 over, and then 3 times 3 is 9. Okay, so 4 root of 2 over 9. We don't know what the angle is, but we know the sine of those, the double of that angle. Okay, so that's that part. Okay, I'll just give you a moment to, if you're writing this down, and give you a moment to copy that down. Go ahead. Okay, now if you didn't get a chance to write everything down, don't worry, I'm gonna post the information on the blog as soon as our video is done. So let's go ahead and use and figure out tan 2 theta. Okay, well, what's tan 2 theta? Okay, so tan 2 theta is the same thing as 2 tan theta. Okay, so instead of alpha, we're using theta symbol, divided by 1 minus tan squared theta. Okay, well, we've already done a little bit of the groundwork over here. Okay, so what can we do to figure this out? So far, the information is the same thing. Sine of theta is negative 1/3, and then we figured out that the cos of theta is negative 2 root 2 over 3. But we don't have the tangent. So the very first thing that we got to do is figure out what the tangent of theta is. So first, determine tan theta. Okay. So, well, what is tan theta? Well, tan theta is the same thing as sine theta over cos theta. Okay. What's a sine theta? Sine theta is negative 1/3 divided by, what's a cos theta? Cos theta is negative 2 root 2 over 3. Now, if we divide these two, the denominators would cancel there. Okay. Or if you can't see it that way, if you're not comfortable with the way I did it here, canceling this, how do I know that cancels? You can say that I'm going to take this numerator, which is a fraction, and then multiply it with the reciprocal of the denominator. And then you will find that the denominator cancels. So how does that look? how does that look? So I'll just go like this. So negative 1/3 divided by negative 2 root of 2 over 3. Okay, so this is like a complex fraction. What you can do is the same thing as multiplying the reciprocal. So 1/3 or negative 1/3 times the reciprocal of the denominator. So if we take the reciprocal of the denominator, we're going to get negative 2 root 2 over there. And then the 3's and the 3's would cancel, and then we're left with just negative 1 over negative 2 root of 2. So over here, okay, what I did here is they have the same denominator, and I can cancel that one. But it has to be numerator, denominator, divided by numerator, denominator. Okay, so that's just some kind of an explanation how I got to that part. This is the same thing as what is that again? Negative 1 over negative 2 root 2, which is the same thing as 1 over 2 root of 2. Okay, so now we know that tan theta is equals to 1 over 2 root of 2. Now that we have this information, we can go ahead and figure this out, evaluate this. So tan 2 theta is equals to 2 tan theta over, let's put a line there, 1 minus tan squared theta. Okay, now I'm going to substitute the values for tan theta. So it's 2 times tan theta. So tan theta is going to be 1 over 2 root of 2 divided by 1 minus 1 over 2 root of 2 squared. Okay. Now it looks like some complicated fraction again going on in here. Let's simplify the numerator. See if we could do that. Simplify the denominator first. We're not going to try to do everything at once. So simplify the numerator. So the 2 in the numerator here, cancel that one. So this numerator will be just 1 divided by root of 2. And then the denominator here, it becomes 1 minus, I'm supposed to square this one. So 1 squared is 1. 2 squared is 4 times root of 2 squared is 2. So that's going to give us root of 2 squared is 2 times 2 squared is 4. So that's going to give us 8. And what's that equal to? So it's going to be 1 over root of 2 over, denominator has different denominators here. So this is going to be 8/8 minus 1/8. That's the same thing as 1 over root of 2 over 7/8. Now these two are not the same denominator, root of 2 and 8. So we can just multiply the reciprocal. So I'm really running out of room in here. So if we multiply the reciprocal, just do that on a separate sheet of paper because I'll write down just one final answer there. 1 over root of 2 times the reciprocal, 8 over 7. So that becomes 8 over 7 root of 2. So that's the same thing as 8 divided by 7 root of 2. And that's our final answer right there. Okay, so in this particular case, just a strategy is to, we are given the information where the angle is. It's nice to visualize it, so draw it out just like the way we did it in here, and then figure out the cos, the sine, the tangent, and then once you have that, we can work out the evaluation process. Okay, so that's that piece. Now let's take a look at example number 2. Example number 2 says given angle theta in standard position with the terminal arm in quadrant 4. Okay, so now they're telling us this is a different picture. It's the angle, but now it's on quadrant number 4. And it says their cosine is 2 over 5, 2/5. So let's draw the picture out. I'm going to draw it up here so that I don't have, so I have extra room. So angle in standard position. Standard position means the initial arm starts on a positive x-axis and it rotates counterclockwise and it finishes up in quadrant 4. So it would be in quadrant 4 here. Yeah, we don't know it's like how far it is, but it's quadrant 4 that way. And what they said is cos is 2 over 5. So cos of theta is equals to 2 over 5. And that's the reference angle right there. So this is the reference angle there. This is going to be adjacent because cosine means adjacent over hypotenuse. Okay. So in this particular case, because it's in quadrant 4, cosine is positive. So this is 2. Hypotenuse is 5. So that's this one. We're missing the y. But the y, because it's in quadrant 4, the y should be negative. So the y should be negative. Okay, so this one here, we try to read our question first, draw it out. It's always a great idea to draw it out so we can see what's going on. So this is a given information. Cos of theta is 2 over 5. So that means if this is the angle right there, and this is the reference angle, so this is adjacent is 2, hypotenuse is 5. We're missing the y. Okay. Well, let's see if we need it. Let's see if we really need it. Just going to grab this one in here. Now, sine 2 theta, we're going to use the identity. This is the only sine 2 theta function in here, right? The identity. Sine 2 theta, or alpha, in this case, is equals to 2 sine alpha times cos of alpha. Okay, let's write that down. So that becomes 2 sine, okay, instead of alpha, they use theta. So I'm going to use theta, cos theta. So in this particular case, we do have the value for cos theta. Cos theta is 2/5, so we have that. But we don't have the sine theta. So what do we do? Well, we got to figure that out. Okay, so I'll just do it over here so we can have lots of room in here. Okay, well, how can we figure out the y? It's x squared plus y squared is equals to r squared. X squared is 2 squared plus y squared is equals to 5 squared. Okay, so now y squared. Okay, let's see if I can just figure out the y. I'm going to go 5 squared, so that's going to give us 25. Okay, 5 squared is going to give us 25. And then I'm supposed to take this 2 squared, bring it to the other side, so that's going to be a minus 4. So that's going to be 25 minus 4, so we're down to 21. And then square root of that, so square root of 21. Now, when we take the square root, we have a plus minus value. So when we take the square root of y squared, we should be taking a plus minus value. But because this terminal arm is on quadrant 4, we would have to take on, the negative root of 21. Okay, so you're probably thinking, well, square root of 21 is positive. That's correct. But because it's in the quadrant 4, it's going to be in the negative. It's going to have a negative y value. Okay, so we're going to take on a negative root, square root. Okay, so now that we have that, this is going to be negative 21 is the y. Therefore, sine is opposite over hypotenuse. So therefore, sine theta is opposite, which is negative root of 21 divided by hypotenuse of 5. So that's going to be 2 times sine. Maybe I should put that in here. Sine theta is equals to negative root of 21 over 5. This is the opposite and hypotenuse. Okay, just in case people are wondering, where did I get those numbers? So I'm going to put that there. So negative root of 21 over 5. And then cos of theta is 2 over 5. 2 over 5. And from here, it's just a matter of just simplifying things out. So 2 times negative root of 21 times 2. So that's going to give us negative 4 over root of 21 over 5 times 5, which is 25. So sine 2 theta is equal to negative 4 root of 21 over 25. Okay. And that is the, I didn't even really read the whole thing. Determine the exact value. Okay, exact value. So there's a way to figure out the approximate value, but this is the exact value. Okay. Just giving you some extra time to just write that down. Okay, now we're gonna go to the B part. Okay, this is the B part. Cos of 2 theta. Cos of 2 theta. Okay, well, how do we do this one? Well, this one we got several choices. You can pick which one you like the best, which I would say pick the easiest one if you can. So let's see here. Cos 2 theta. Well, what's a cos 2 theta? Cos 2 theta, we have these possible choices. We can either go cos squared of the angle minus sine squared of the angle, or we can go 1 minus 2 sine squared of the angle, or we can go 2 cos squared of an angle minus 1. So we got some choices there. We got 3 choices, and we have all of the information for any of them. So in this particular case, okay, any one would work, but here's the easiest one of all, right? Because we already are given the cos theta, which is 2 over 5. 2 over 5. Let me take this again. We already have the cos. I can just do this one. Okay, I can just do this one. I don't have to figure out the sine. If I didn't have the sine theta figured out, I can just go straight to this one, and I don't need a sine value. So that's my shortcut. I'll go with that one. So 2 cos squared theta minus 1. Okay, so what does that equal to? 2 times cos squared of theta minus 1. Well, cos squared of theta means, okay, it means 2 times cos theta squared. Okay, we're not squaring the theta, we're squaring the cos of theta minus 1. I want to write that down so that everyone is clear on what cos squared of theta means. So what does that mean? 2 times cos theta. Okay, so cos of theta, we know it's 2 over 5. Now we put squared minus 1. There we go. And then we're going to do the orders of operation. Exponent first, then multiply, and then subtract. So 2 squared is 4 over 25 minus 1. Okay. And then I can go like this. 2 times 4 is 8 over 25 minus 1. And 1 is the same thing as 25 over 25. So that's equal to negative 17 on 25. Okay, negative 17 divided by 25. Now there's another way of doing that using the sign as well. So if you choose either one of these two, we're gonna get the same answer. Okay, so I won't dive right onto that one, just because we're saving some time. Okay, so let's take a look at example number 3. Okay, write each expression as a single trigonometric ratio. Okay, so this one in here, they're writing it as a single trigonometric ratio, and then evaluate where it's might be possible, if it's possible. Okay, so if you have sine pi by 3 times cos pi by 3, okay, we can say we can take a look at this one in here. So sine of pi by 3 and then cos pi by 3. So I'm just going to write that down for a second here. We know that sine 2 times pi by 3. Okay, well, this one's pretty easy. We can evaluate it as it is, but they want us to write it as a single trig ratio. We know it's 2 times theta is equals to 2 sine theta cos theta. So if this is what we have, then that means we can divide it by 2, divided by 2. That cancels. Okay. So now, in this particular case, we can write this as sine, instead of 2 theta, the theta would be pi over 3, 2 times pi over 3 divided by 2. Okay, so this is not squared. That's going to be 2 times that pi, which is the same thing as sine of 2 pi by 3 divided by 2. The next part is we can evaluate. Now we can evaluate either way. We can evaluate this part in here. It doesn't really matter, right? So we go sine of 2 pi by 3 over 2. Well, where is 2 pi by 3? Where is 2 pi by 3? Okay, so we learned that 2 pi by 3, this is pi by 3, 2 pi by 3 is in quadrant 2. It's one of the special angles. So this is going to be 1/2, comma, it's negative 1/2, comma, root 3 over 2. So sine of 2 pi by 3, which is root 3 over 2, divided by 2. So that's going to be the same thing as, okay, root 3 over 2 divided by 2 is going to be root of 3 by 4. Root of 3 by 4. So we could do that. Or the possibility is sine of pi by 3 cos of pi by 3, because we know what sine of pi by 3 is. Sine of pi by 3 is 1/2, comma, root 3 over 2. So if we go sine of pi by 3, which is root 3 over 2, times cosine of pi by 3, which is 1 over 2, 1/2, the same thing as root 3 over 4. So we can use our simplified trig single term trig ratio, or we can just calculate it from here. Either one, it works well. Okay, so let's try this one. What's going on in here? We got 6 cos squared theta minus 3. 6 cos squared theta minus 3. Okay, well, we don't have a trig ratio for that, right? So if you take a look at this, we don't have a trig ratio for 6 cos squared theta minus 3. But what can we do? Okay, what we can do is we can factor out a common factor of 3. Okay, we can factor out a common factor of 3. So it's going to be 3 times cos, or 2 cos squared theta minus 1. Now this part here, that part, that's going to be 2 cos squared theta minus 1 is, okay, so 2 cos squared theta minus 1, that's the same thing as cos 2 of the angle, right? 2 cos theta minus 1. Instead of theta, they use alpha here. So we can simplify this part with 3 times cos 2 theta. And in this particular case, we cannot evaluate this. We cannot evaluate this because we don't know what the theta is. Here, we cannot evaluate because we don't know what theta is. And we don't have any information about that. Okay? So that's that. So we did example 1, we did example 2, we did example 3. Now we're going to get into example 4, which is proving. So we're going to talk about proving. So it's on page 23. Proving that this is true. Okay. So I said that to do this, we have to look at the more complicated part or more complicated side and then simplify that one instead of the other one. Okay, so in this particular case, this one looks the more complicated, whereas this one is just going to be 1/2 1 over 2 sine squared theta, sine squared of x. Okay, so we're going to start with this side. This is the left side. and then the right side. Okay. I just want to remind everybody again that because we're proving, okay, proving, we are not switching back and forth terms, okay? We're not cross multiplying or anything. We're just leaving it the way it is and then working it out to see that the left side is going to be, if it's going to be equal to the right side, okay? So no switching around, no cross multiplying whatsoever when we're proving. So having said that, what can we do? Okay, cotangent of x. Okay, well, what do we know about cotangent of x? Um, in a previous lesson, we said cotangent of x is the same thing as cos of x divided by sine of x. Okay, well, that one is good. And then what about cosecant 2 of x? Well, cosecant is, what do we know about that? Cosecant is the reciprocal of sine. So we can write that. Okay, let's write it as, it's going to be 1 over sine 2x. Okay, this is 2 times x. Okay, not squared, but sine 2x. Okay. Okay, well, we can't multiply these two to make a cube. Like, what can we do? Okay, because this is sine of x, and then this is sine of 2x. Well, what can we do next? Well, what's sine 2x? Well, what can we do with this one? Well, we can rewrite that as 2 sine of x times cos of x. So let's write that down. Cos of x over sine of x. And instead of writing 1 over sine of x, I'm going to write the identity for that one. The identity would be 2 times sine of x times cos of x. Okay. And then from here, we can see that some common factors do cancel. So cos of x cancels. With this cos of x, that cancels. So what's left over is just the 1 in the numerator divided by sine of x times 2 times sine of x. That's going to give us 2 sine squared of x. Okay. We have to be careful here that we're writing down a square, not 2, not 2x, it's square of x. Okay, and that's the same thing as the right side. 1 over 2 sine squared of x. So left side is equals to the right side. Okay. So this is really not a bad trig identity to prove. Okay, so certainly do use the stuff that you know about trig identity, and then we'll go on from there. Okay, now let's go to this one, letter B. 1 minus cos 2x divided by sine 2x equals to the tan of x. So the complicated one is on the left side, and then the right side is just a tan of x. Okay, so that's just tan of x. So what can we do to make all of these equal to just tan of x? Do we know? So 1 minus cos 2 of x. Well, cos 2 of x, we can write it as 1 minus sine squared of x. Okay. Cos 2 of x. Cos 2 of x, we can write it as 1. Let me write that down first. It's going to be 1 minus, so cos 2 of x, I'm going to write it as 1 minus 2 sine squared of x. Okay. divided by sine 2 of x. Well, sine 2 of x, we can rewrite that as 2 sine of x times cos of x. Okay, so in this particular case, we can definitely clean things up in here. So 1 minus 1, that's going to give us a 0. Negative times negative 2 sine squared of x, that's going to give us a positive 2 sine squared of x over 2 sine of x cos of x. And then we'll see that there are common factors that can be canceled. The 2 cancels. And then this is a sine squared of x and then the sine of x. So sine of x will cancel one of the factor of sine squared of x. So that's just going to be sine of x over cos of x. And when we have sine of x divided by cos of x, that's the same thing as tangent of x. Okay, so we have the left side equals to the tangent of x, and then the right side, which is also a tangent of x. So that means left side is equal to the right side. Okay, so that's pretty cool, pretty good. If you have any questions, please do let me know through the email, and then I can certainly write down the full solution, or I can, I don't know, I'll somehow touch base with you and help you out. Okay, so we're on page 24. Okay, so we're chugging along in here. Actually, I think page 24, I put these in the Desmos, and I did not get an identity at all. So this one here, we're going to omit this one. It's not, we can try our best to do that. It's not going to be an identity. So they are not an identity. So we're not going to waste our time on that one. Try to figure that out when it's not even an identity. So let's go ahead to letter D. What's going on in here? Oh, so we got sine 5x cos 3x minus cos 5x sine 3x. That's kind of reminds me of the sum and differences of trig identities, right? So sine cos minus cosine. So sine cos. Let me see your focus. Sine cos minus cos sine. So that we can rewrite that as sine of first angle minus second angle. Okay, so this really reminds us of sine Oh, I don't have room. I'll just go like that. So this is the sum, the difference of two angles. So this is sine 5x minus 3x. And when we have that, that's the same thing as sine 2x. Okay, well, if we have sine 2x, that's the same thing as 2 sine of x cos of x, which is equal to the right side. Okay, so this is really a not so bad one. We just have to realize that this is the difference sum difference trig identity. Okay. In this particular case, it's difference. Okay, so left side is equal to the right side. Okay, so what have we done so far? So far, we've talked about evaluating expression. We also talked about proving identities using a um, double double angle trig identity. So the last bit is the last two examples, which is solving. So solving means we're gonna find an angle that goes with this one in here. Okay, so we're gonna use our trig and our trig identity. Also, because we are solving, it's okay to move terms to the left side or the right side, right? So that is okay. So let's give it a try now. So cos of 2x. Now, cos of 2x, and then here is sine. It would be really good to put everything it is in terms of sine, if it's all possible, because I got a sine here, and then this is a cos 2x. So cos 2x, I know we have some choices. Okay, we can write it like this, we can write it like that, or we can write it like that. Okay, so it doesn't. So in this particular case, we're just going to use this one because in our equation, we have sine of the angle. So cos 2x, we're going to write it as 1 minus 2 sine squared of x. Okay, now you got to make it squared x. Okay, not 2x, it's squared x. Equals to 1 minus 2 sine x. So now we're gonna figure out in here that everything is sine, and then we're kind of looking at the trig, a quadratic trig equation. So put everything on one side. So 1 minus 2 sine squared of x. And then if I bring everything on one side, negative 1 plus 2 sine x equals to 0. And then we can clean that up, of course. So 1 and negative 1 cancel each other out. Okay. And then this one here, they don't cancel because this is a negative 2 sine squared of x, and this is positive 2 sine of x. These are not the same. So that becomes negative 2 sine squared of x plus 2 sine of x equals to 0. Okay. So what can we do? Well, the way to do this one here is we can factor out a common factor. We can factor out a common factor of negative 2 sine of x. Okay, so if we factor out the negative 2 and then the sine of x, we can take out the negative 2 and then the sine of x, so we're left with sine of x, and then it's going to be minus 1. Okay, so now we're going to use the zero product property. So that means negative 2 times sine of x times sine of x minus 1 will give us a 0. So this part here, sine of x is equal to 0. So we're looking for where is sine of x 0? Sine of what angle is at 0? So sine at 0 is here. Again, our domain is from 0 to 2 pi. So that means x is going to be 0 radian. 0 radian. Okay. We could have gone 2 pi, but the domain here is not including 2 pi. Okay. Now what about this part? Sine of x minus 1 is equals to 0. So therefore, sine of x equals to 1. So where is sine of x 1? Sine of x is 1 right there. So that's going to be at x equals to pi halves. So therefore, there are two solutions. X is equals to 0 radian, and the other one is pi halves. So pi halves, you can put radian, or you can just leave it as pi halves, because when it's pi, it's understood it's radian mode. Okay, so there's so much concept in here that is absolutely important. So from factoring to substitution to unit circle, that's so much information, so much concept understanding goes into this kind of question. Okay, so now let's take a look at this part in here. A half sine 2x minus cos squared of x equals 0. Okay. Now because this is 2x, so we can use the trig identity for the double angle. So how can we replace this part in here? So we can replace that. Okay. So instead of sine of 2x, we're going to use 2 sine x cos x. And that's the only choice that we have. Okay, we don't have any other choice. So 2 sine x cos x minus, brackets, cos squared of x equals to 0. Okay, let's see if we can clean this up. So the 2 and the 2 cancels each other out. So we're left with sine of x cos of x minus cos squared of x. Now you're probably thinking, oh no, this is a quadratic, but then it involves two trig functions. We got some sine and we got some cos. So what can we do here? Let's factor out the greatest common factor. So let's factor out common factor. Let's do that. There's a common factor of cos of x. So cos of x. Okay, so sine of x minus cos of x equals to 0. Okay, so now we got this factor over here. So we're going to use a zero product property. So cos of x equals to 0. So we have to take a look. Okay, at what angle do I need that the cos of that angle is 0? Well, you could use your calculator, certainly. You take cos inverse of that. That's going to give us here and here. Okay? Or having our understanding of a unit circle. Cos are the x values of the unit circle. So cos of the angle at 0. So 0 here at pi over 2 and 3 pi over 2. So x is equals to pi over 2 and 3 pi over 2. So you got two solutions just for that part. And then over for this one, sine of x minus cos of x equals to 0. So how can we do this part in here? Well, let's see. If I bring this over there, we're going to get sine of x is equals to cos of x. So we have to take a look. Where is sine of x? Sine of the angle is going to give us the same cos of the angle, same value. The only place that that's true is at the reference angle of 45-degree angle. Okay, so here, this is only true if we have a pi by 4, right? This is a pi by 4. So at pi by 4 here, the cos of x and sine of x are equal to each other at root 2 over 2, root 2 over 2. They're equal. At the same time, they're also equal right here. Okay, so we can say, hey, that's also at what pi over 4? That's 5 pi over 4. 5 pi over 4. At 5 pi over 4, this point there is the same thing as negative root 2 over 2 and negative root 2 over 2, which are equal to each other. Okay. Another way of thinking about this, okay, just kind of reminded me of this. Another way of thinking about this is this. We know that the sine of x is equals to cos of x. So if I go divide by cos of x on each side, cos of x on each side, sine of x over cos of x is equals to 1. Oh, sorry. Wrong side. Sine of x over cos of x, that's a tangent of x over is equals to 1. So we can think of it, oh, where is tangent of x equals to 1? Well, tangent of x is equals to 1 at pi by 4 and 5 pi by 4. Okay, so this is the other way of thinking about it. And 5 pi by 4. Okay, so in this particular trig equation, there are 4 solutions. So there are 4 solutions. There are 4 solutions. Okay, so the first solutions are pi by 2 and 3 pi by 2. X is equals to pi by 2 and 3 pi by 2 and pi by 4 and 5 pi by 4. And that's it. Those are the only solutions within the domain of 0 to 2 pi. Okay, so there you go. That is the conclusion of this booklet. We've done so much on this particular topic. And I just want to say thank you very much for watching, for participating, and for continuing on till the end. So there are some practice questions for us to try. Okay, so page 658, questions 5 through 18, and multiple choice 1 and 2. Give those questions a try. If there are some questions in here that you don't understand at all, please let me know, and I will help you out. So to kind of remind ourselves, we have today to work on some of these questions, and then our test is on Friday. I will post a test on Friday morning, and then you will have, okay, if you finish the test right away, hand it in, and then you're done. Otherwise, the absolute deadline would be Monday. Okay, so Monday, that's the absolute deadline for it, just because I have to mark it, do your report card, and then I gotta figure out who's graduating, who got a credit, who's moving on, and so forth. So just to let you know that that's gonna be our plan for the next the rest of this week, and next week on Monday. Okay, so, anyways, thank you so much for watching. I will leave you with these questions for you to try. And yeah, um, you can get a hold of me through email if you have a specific question that you want me to go over with you. Okay, so have a great day, everybody, and I will talk to you soon. Okay, thank you, and bye for now.